Welcome to Stress-Free Coding Channel, HTTP Part 2. I'm Sto. So let's start right away. Today I will talk to you about these topics: short live connection, persistent connection, HTTP pipeline, HTTP multitasking. Hey, stop. Okay, maybe I'm exaggerating. Every time we look at the web page, our browser says to the server, "Hey server, give me the CSS files, and now give me the JavaScript files. And again, give me image 1 in JPEG, image 2 JPEG, and keep it up." So when the browser talks with the server, connection is necessary, just like when you talk with your friend by phone. Starting from version 1.1, HTTP connection between client and server have been made much more efficient with the introduction of different connection models. Persistent connection and HTTP pipeline. Compared to the HTTP 1.0 version, which use exclusively short-lived connections. What is a short-lived connection? When client and server communicate by short connection, new connection is opened at each request, which start and end with the request itself. This means that TCP transport protocol must be performed handshakes each time, with a consequent increase in waiting time. A short connection, also called cold connection, is not very efficient, as the TCP protocol favors persistent connection, also called warm connection, to optimize the load. Instead, a persistent connection is one which remains open for a period of time and can be reused for several requests, saving the need for a new TCP handshake, and utilizing TCP performance enhancing capabilities. A persistent connection will not stay open forever. Idling the connection are closed after some time. A server may use the keep alive header to specify a minimum time the connection should be kept open. Persistent connection also have drawbacks. Even when idling, they consume server resources and also come under DOS attack. HTTP pipeline. Requests based on the pipeline model send successive requests over the same persistent connection without waiting for the answer. This avoids latency of connection. Theoretically, performance could also be improved if two HTTP requests were to be picked into the same TCP message. However, the pipeline model has different drawbacks. Pipeline is complex to implement correctly. Important messages may be delayed behind unimportant ones. Buggy proxies are still common, and these lead to strange and erratic behaviors that the web developers cannot foresee and diagnose easily. For these reasons, pipeline has been superseded by multiplexing that is used by HTTP2. HTTP2 multiplexing reduces latency by request and response, minimizes protocol overhead by an efficient compression of HTTP header, and adds support for messages prioritization. HTTP2 allows you to send multiple requests on the same connection to fully utilize on the one single connection. All these requests make their way through the internet of a server in parallel. The server responds to each one, and then they start to make their way back. This model has the benefit that one heavy request does not block all the other subsequent requests. The web browser then is tasked with putting all the pieces back together. Now, you may be wondering that to take advantage of multiplexing, you will have to rewrite part of your code. The good news is that all the core concepts found in HTTP 1.1 remain in place. Instead, HTTP2 modifies how the data is formatted and transported between the client and server, both of which manage the entire process, and hides application complexity within the new framing layer. As a result, all existing applications can be delivered without modification. Okay, that's all for today. Like and subscribe to the channel for our next stress-free coding video. Bye.